Bismillahirrahmanirrahim. Hello guys, how are you? In this video we will discuss about automatic indexes. How does automatic indexing works? Auto indexing relies on a task that is invoked periodically in the background. The task creates a set of candidates. Auto indexes in each iteration based on column usage information, column used in SQL statement, predicates. These indexes are initially invisible and unusable. They are metadata only and invisible to application SQL. A subset of application SQL captured in the automatic SQL tuning set is used to validate whether candidate indexes are worth building. The validation consists of two steps: compilation, to check whether the optimizer would choose the new indexes, and then execution, to check the performance of the SQL statements after building the indexes. SQL statements used to validate index performance from the automatic SQL tuning set are subject to a 30-day testing cycle. So once used, there is a 30-day period before SQL statements are potential candidates for retest. After the validation, there are two possible outcomes. If SQL statement performance is improved, all indexes built in the current iteration are marked as visible, and any SQL statements that suffer performance regression will acquire SQL plan baselines to prevent them from using the poorer plan. If no SQL statements have significantly improved performance, the newly created auto indexes will remain invisible. Indexes built without delivering performance benefit will be made unusable after 24 hours, reducing the number of auto indexes maintained in the system. Index usage is monitored and an index will be dropped if it has not been used for 53 weeks by default. Checking the automatic SQL tuning set. Historical SQL execution statistics for workload queries are critical for database automation. In addition, a record of workload queries is essential to measure the performance impact of making changes in the database. For this reason, a database infrastructure component called the automatic SQL tuning set was conceived. The ASTS means automatic SQL tuning set is a system maintained SQL tuning set called sys_auto_sts that acts as a source of historic SQL performance metrics and execution plans. SQL statements captured can be seen in the view dba_SQL set_statements. As you can see the select statement, you can run that and you can see as select SQL ID SQL text from DBA SQL set statements where SQL set name equals sys_auto_sts. There is a dedicated task for populating the SQL tuning set. It is important that the task is running for automatic clustering to function correctly. This can be checked as follows. As you can see the command written there, select task name enabled from DBA auto task schedule control where dbid equals 6 underscore context user env comma con dbid and task name equals auto sts capture task. From Oracle database 21c, the view dba auto task settings view exposes task settings instead of dba underscore auto task underscore schedule underscore control. The automatic SQL tuning set task will start without manual intervention when automatic indexing is enabled, so there is no need to start it manually. However, for your reference, it can be started as follows: begin dbms underscore auto underscore task underscore admin dot enable. Here you have to define 3 parameters: client name, operation, and Windows name. You must not disable the automatic SQL tuning set task if you want to use automatic indexing. Checking and configuring the automatic indexing background task. A background task implements automatic indexing. It can be seen as follows. Same data dictionary table, DBA auto task schedule control. By querying task name, enabled, and maximum runtime, we can see the values as you can see here. The task is automatically enabled when auto indexing mode is enabled with implement. The automatic SQL tuning set task is also enabled. The task has a maximum runtime of 3600 seconds. For systems with large indexes, it may be necessary to increase this as follows. By this command, you can see dbms autotask admin dot modify underscore autotask underscore settings. Here you mention auto index task and then maximum runtime and the value 7200. For example, default was 3600. Now we increase it to 7200 seconds. You can assess the need for increasing the maximum runtime by inspecting the elapsed time value. If it is consistently matching the maximum runtime, increase maximum runtime. So by this command, you can see select task name, elapsed time from DBA autotask schedule control, same where clause. In task name auto index task, here you can see elapsed time is 3610. For example, this is example. Controlling automatic indexing. The DBA auto index.configure API is provided to configure automatic indexing. In Exadata environments, you will typically adjust auto index default table space with the command execute dbms auto index.configure. Here you can mention the table space for that. You can target auto indexing at specific schemas using inclusions. Here you can see this to include and exclude, both are mentioned here. For include, you can run auto index.configure, parameter name, auto index schema, parameter value HR, allow true. And the other section in exclude, we mentioned false. False is to disable and or exclusion. If it is useful to adjust the report retention period to suit your requirements, automatic indexing can generate significant metadata in the advisor framework stored in CSOCs. You may want to reduce the reporting history period to reduce space consumption. So in the example, it is set to 31 days. The default is 373. As you can see, the command execute dbms autoindex.configure report auto index report retention 31. By default, unused auto index are dropped after 373 days. Manually created indexes are not dropped by default, but a drop period can be set. 600 days in our example, it is defined. Enable automatic indexing as follows. By this way, we can enable automatic indexing. We mentioned here dbms auto index.configure auto index mode implement. So it will enable. Disable, we have to just mention off. For enable implement and for disable off. Same command. dbms auto index configure. Note that settings automatic indexing of disables housekeeping tasks such as repository purging and dropping unused indexes. You can check the current configuration by using following command. Select parameter name, parameter value from dba auto index config to check order by parameter name. We mentioned here order by 1. By this way, you can see the parameter value defined for every parameter name. Optimizer statistics. Auto indexing test executes workload SQL and it demands that table optimizer statistics are not stale. Make sure optimizer statistics are fresh and maintained using the high frequency statistics gathering task. The maintenance window task where active or manually. Automatic indexing. Evaluating automatic indexing with report only mode. Automatic indexing can be initiated in a report only mode. Execute dbms underscore auto underscore index dot configure auto index mode report only. In this mode, indexes will be created and tested but will not be visible to the application. Since valid indexes are created using the process, auto indexing may affect DML performance to some degree even in report only mode. Query performance will remain unaffected because the indexes remain invisible. If the auto indexing mode is changed to implement, valid invisible indexes are made visible. If you want to evaluate auto indexing without modifying a production system, then create a clone. If the application workload is present in the automatic actual tuning set, the clone will have it too. Enabling auto indexing on the clone will trigger the process of auto index creation. If you want to copy automatic indexes created on the clone, there is an example of how to do this. It is available on GitHub repository. The automatic indexing report. Reports can be retrieved using report underscore last underscore activity and report underscore activity. For example, the last 2 days can be reported as follows. First, you need to set some values like line size, trims, page size, long, it's your choice. And you can define the format for report hist column A120 and variable rep clob. Then you can execute rep equals dbms underscore auto underscore index dot report underscore activity. Activity start sysdate -2 parameter and section parameter is all, level is all. So you can spool the output, like spool report hist, select :rep, because rep is a variable we defined as a clog from dual. So then spool off, so the value will be written in spool. So if we want HTML version, we can generate HTML format as well. For that, :rep dbms auto index dot report activity. We mentioned type HTML. So after level, last parameter we defined as a type HTML. So now we can spool again in the HTML format, and we take select, so it will generate a HTML file. Identifying automatic indexes and understanding index states. Do not alarmed if you see a large number of invisible and or unusable indexes. This is normal. Indexes can exist in a variety of states. This can be seen as by running the following command: select index name, status, visibility from DBA indexes. Automatic indexes have a system generated name. You can identify them as follows by running the below command: select index name, status, visibility from DBA indexes, where auto equals yes. So it will show you all the indexes auto created. Now we have different kind of index states. In the context of automatic indexing, index states have the following meaning. So this is important, like you can see: state valid, invisible, a usable, or an invisible index. The index is not visible to the application workload and was built in anticipation of it being of performance benefit. However, auto indexing test execution, if it has completed, established that the index did not significantly improve performance, so it was not made visible to the application workload. After 24 hours, the index will be made unusable. Invisible, provided the automatic indexing task is not disabled. Valid, visible, a usable or visible index. The index improves SQL performance and is visible to the application workload. Unusable, invisible, and unusable, invisible index. The indexed column or columns are used in SQL predicates, but the optimizer chooses not to use the index during the validation step. The index remains as metadata only, so there is no overhead associated with index maintenance, and the index is not visible to the application workload. Or the index was previously valid, invisible, and was not found to be beneficial, and after 24 hours was made unusable. Or the auto index task max runtime may not be long enough. So you can check the checking and configuring the automatic indexing background task above we mentioned. If automatic indexing is set to report only mode, indexes are still created, both valid and unusable, but they wouldn't be made visible to the application workload. Mixing manual and automatic indexes. You do not need to drop manually created indexes when you enable automatic indexing. Auto indexes are created on an as needed basis, measuring the performance of SQL statements to decide whether any additional indexes will deliver a performance benefit. In addition, you can create or drop manual indexes anytime you like. By default, manually created indexes are never dropped by automatic indexing. Nevertheless, if you want the feature to identify and drop unused manual indexes, you can use DBMS underscore auto underscore index dot configure to set an auto index retention for manual period. Functional based auto indexes. It is common to encounter SQL statements that include predicates similar to the following. Select COL from tab where upper customer name equals Smith, or second command you can see select column name from EMP where NVL EMP number comma MGR greater than 7800. The performance of queries like this can be improved significantly using function based indexes like create index. Any name you can mention here. For example, I mentioned cust name IDX on user data upper customer name, or with NVL also we can create index. Automatic indexing from Oracle Database 23C leverages expression tracking to identify functions used in SQL predicates. It will create and test candidate functional indexes. Dropping automatic indexes. Automatic indexes cannot be dropped using the drop index DDL command. Instead, drop underscore auto underscore indexes is provided instead. You can see the command execute dbms underscore auto underscore index dot drop underscore auto underscore indexes. Then you mention schema and you mention index name and comma true. Automatic indexes have a mixed case name, so it is important to include double quotation marks. The API will accept null for name and schema. For example, in the next command will drop all automatic indexes for the SH schema. This is especially useful if you intend to test automatic indexing multiple times on the same schema. You will need to drop indexes with allow underscore recreate equals true so that the test will rerun successfully. Execute dbms auto index dot drop underscore auto underscore indexes, schema name null true. The third parameter, allow recreate, is important. True means that auto indexing will recreate the index if it is deemed beneficial again later on. False means that an automatic index will never be recreated. If an index was dropped using the command execute dbms underscore auto underscore index dot drop underscore auto underscore indexes, schema and index name false, it is possible to undo the decision to prevent recreation and allow the index to be recreated. Even though the index will not exist, the command will succeed. So you can mention again same command with true parameter. Automatic index types. Automatic indexes are currently non-unique B tree only. Partitioned indexes are local if the index key is prefixed with the same column as the partition key, global otherwise. Schema, more about schema and table inclusion and exclusion. You can include and exclude specific schemas using the auto underscore index underscore schema parameter in dbms underscore auto underscore index dot configure. Oracle Database 21C introduced auto index table at the time of writing. This has not been backported to Oracle Database 19C, including Oracle Autonomous Database. DML Awareness. Indexes do not come for free. In general, indexes will reduce the cost of executing queries by will increase the cost of some DML operations. Prior to Oracle Database 23C, DML was not costed, so systems with very high insert, update and delete rates could see performance degradations in some cases. Oracle Database 23C weighs the increased cost of DML when indexes are present against the reduced cost of executing queries on relevant tables. When enabled, indexes may not be created on tables subject to high DML activity. DML costing is enabled by default and it can be turned on and off by following commands: execute dbms underscore auto underscore index dot configure auto index include DML cost on, or you can make off this parameter. This is like switch to make on off. Thanks for listening. Hopefully you will understand by this article. It was very good. So definitely by practicing this you will understand more. But I will suggest to practice this on test environment first, then go to production. It is a very nice feature for automatic database, and definitely it is a big relief for DBAs. But as they mentioned here, it is not free. It has some cost of executing queries for performance, but at the end it is a very good thing. Like sometimes we create so many indexes for time being and they were never used again, and mostly those indexes are keep staying in the database. So this is a very nice feature, so I believe that I should share with everyone. Thanks for listening again, and we will meet again in next video. Till then, thank you, goodbye. Don't forget to subscribe, please.